So, hello, welcome back to another day of Advent of Code. Um, yeah, so last week's challenge, yesterday's challenge was writing a kind of like a CPU for a handheld console, which is one of my favorite programming challenges. And yesterday I wrote something a bit hacky. It just kind of worked, and so afterwards I tidied it up a little bit, and I've kind of put together this little this kind of mini module, mini library to package all of that stuff into something that's nice and easy to work with. And so if you saw yesterday's stream, you'll have seen I had something that looks like the step function here, which has the switch on these instructions that the CPU would be able to read. This not, ACK, and jump instructions. The reason I did this is because last year there was a series of challenges that was similar to this, where we had to build up this thing called an intcode machine. And some of the challenges would depend on your implementation from the weeks before. And so just in case that today is an extension of this problem, I've kind of put it together into a nice little library. Now chances are today won't be this. Last year it was like every third challenge or every fourth challenge was one that depended on the intcode machine. But I did this, put this together just in case. So it's got all these instructions, it's got a few helper functions to check if we've hit an infinite loop or if we've terminated our program, just a little debug to print some of the internal state of this out, and a couple of helper functions to parse code and things like that. And so the way this works is, so you can see I've put this together for today's challenge already, just in case we might need it. So the way I've made this work is you import it, you parse the input, which is an array of these instructions over here. You make a new CPU. I just called it P1 because I'm bad with variable names. And then as long as it hasn't terminated, you just keep stepping through it until you're finished. And once you're finished, you debug it. And so I've actually put together yesterday's challenge using this bit of code. This was yesterday's challenge. So I parse it into this prog. Yeah, so the first part, it was it asked you what was the state of the CPU the moment the program hit an infinite loop. So while it hasn't looped, keep stepping. Once it has hit an infinite loop, it will stop, and we just printed out the state. And then the second half of the program was a little bit trickier. It said one of the instructions was wrong. Either a NOP was meant to be a jump, or a jump was meant to be a NOP. And then it asks you to figure out which one it is. And so to do that, I just looped over the program, changing every single NOP or jump to the other one at a time until we found the correct instruction to fix, which would halt the CPU, which means the program terminated properly. Once it did, we printed out the internal state, and that was that challenge. Yeah. And so that did yesterday's challenge very well. But that is not today's challenge. Today's challenge, we have no idea what it is, but we're waiting for it to come up. We have 1 minute left. And so I've just put this together just in case we need it. So then I've got all the boilerplate ready to go. But if it's not, then it's easy. We can just delete this code. And I'll put it together for next one. I'm kind of hoping it is, but I'm pretty sure it won't be. So yeah, we have 1 minute to go. I think we just have to wait. Yeah, and yesterday I had a viewer, Blue Ghost, I think his name was, and he was really helpful. He helped me with quite a few things. So if you're watching and you see that I'm doing something that's silly, something that could be done a better way, do let me know in the comments, in the chat, and I will do my best to reply. All right. This is that last little awkward few seconds of waiting to see what's happening. I guess I should put this together. There we go. So we have that ready. Okay, here we go. Wish me luck. Yeah, so this doesn't look like one of those CPU questions. That's fine. Okay, it says there's some random... Okay, so there's a port on my plane seat, I think, and I'm hooking something up to it and I'm getting some data out of it, and I think I'm trying to figure out what it means. Okay, so it starts with a preamble with 25 numbers. After that, each number you receive should be the sum of any of each number you receive should be the sum of any two of the 25 immediately previous numbers. The two numbers will have different values, and there might be more than one pair. For example, suppose your preamble consists of numbers 1 through 25 in random order. To be valid, the next number needs to be a sum of any of two numbers. 26 will be valid, 49 will be valid, 100 would not be because you can't. 50 will also not be valid because you need to add two different numbers. Suppose the 26th number is 45, and the first number, no longer an option, as it is more than 25 numbers ago, was 20. Now for the next number to be valid, there needs to be some pair of numbers between that, or that add up to it. In this example, after the 5-number preamble, almost every number is a sum of two of the previous 5 numbers. The only number that doesn't follow this rule is 127. First number is defined, which is not the sum of two numbers before it. What is the first number does not have this property? All right, so this seems like some kind of optimizing problem. I feel like this is something along the lines of like dynamic programming or something like that. But I really don't have the experience to write something that works for that. So we'll have to make do with something a little simpler. Now I'm fairly certain that if we try to brute force this and check every pair of 25 numbers before each number, it's going to take forever. But there should be a way to simplify this, right? We just need a way of keeping track of all the previous numbers that we are allowed to look up. If you're adding 25 numbers together, how many pairs of numbers are there in 25? Pairs. That's not going to do it. (25C2)? I feel like this is like 25 times 24. I don't know why I'm doing this. No, it's 25 times 24 divided by 2, right? 300. There should be 300 pairs of numbers. 300, yeah. Cool. So we need to build up a list of every set of numbers. Should I just try brute force this and see what happens? List then put that length I++. How long is that list? 1,000. We start at the 25th number actually. For equals I minus 25, j less than I, j++. Yeah, see, this is going to take forever, right? This is like this is like n cubed. Maybe this will work for the first part, but it definitely will work for the second part, I'm thinking. If input I is input j plus input k, we're done. If it equals it, that's fine. We're done with this loop, and we continue outer. No, we got to break inner. If not found, then we're done. We don't need to print I because we're printing every loop anyway. Cool, let's see what we get. Break. Not found. Okay, we did just brute force it. That's okay. 6178. 6931, 6178. Well, turns out we can brute force easy stuff like this. Final step in breaking this XMS encryption relies on an invalid number just found. You must find a contiguous set of at least 2 numbers in your list, which sum to the invalid number from step 1. So I need to find a sequence of numbers that add up to this number. Huh. So I'm trying to find some. For this first part, all I did was just brute force every single number and checked every possible pair of numbers to see it. Like I literally did what it said in the question with no optimizations whatsoever, and it was pretty quick. But the second part, of course, yeah. So second part is pretty straightforward too. So I already know my target is this number, right? And I know that, well, why is my const index is 555. That's the number I couldn't find, right? Was at index 555. Why is my cursor doing weird things like that? Not sure. So all I have to do is loop every number from the beginning, and then just keep summing up all the numbers after it until we hit a number that is greater than this number. If we hit a number greater than this number, we didn't find it, and we should move on to the next one, right? And if we hit the number, then we get it. If for, let's j equals, let's see. Yeah, so let sum equals input I. Sum plus equals input I plus j. So we're just adding, so we're just kind of starting from the first number, adding the next numbers all the way down until we either hit a number that is, cool. Until we hit a number, if it equals our target number, then we're done, right? We just want to print out I, which is the number we started at, and I plus j, which is the number we finished at. We also want to print out input I, and we want to print out input I plus j. Just print out as much information as you can. Otherwise, if sum is greater than target, then we can't add it up anymore. Then we can't find any more numbers. Then we've already passed our limit, right? So we continue outer. And we start again at the next number. And I mean, that should just work. Console.log. Cool. So to add together small and large numbers in this contiguous range, for example, 15 and 47 produces, so this actually might not work because the numbers do kind of go down, but I'm going to pretend that this works and see what happens. Producing, yep, cool. So 3205921 plus 5221148 is this. Should work. That's not working. What? Did I say find the first? So 3 is 0, right? Minus 3. So we want to go to 4, 4, 4, 5. Oh, add together the smallest and largest numbers in this range. Right, not the first one and the last one, but the smallest number in the range. Oh, no, because it does go down. Hey. So, I mean, technically this algorithm won't always work, I think. But, no, I need the other way around. But it should work for this case. Right, that compiles, right? Yeah, okay. So let's see. The smallest should be input I, largest should also be input I. Sum plus equals that. If input I plus j is smaller than smallest, then smallest should equal input I plus j. If it's greater than largest, then largest should equal that. If we've found it, we'll print together a smallest, largest, and smallest plus largest, which was what I misread. Yes, that should be our answer there instead. Got it right, 700th again. All right, so I'm getting around 700th place on average, it seems, for both questions. You know, I'm a little bit sad, but it's all about practice, right? If I haven't coded in 2 years, I should be pretty happy with this result. Yeah, today's question was interesting, I'd say. I feel like with the first part, so what I did with the first part, like I did, was I just brute forced every pair of numbers within the 25 before each number, right? And I feel like I didn't have to. I feel like there's some way to optimize this. I could just read the next number, add that to the previous 25 numbers, tack that onto the end of the list, and then make sure I only check like the last 300 numbers in that list or something like that. I feel like that should work, but and that would be a lot more efficient, right? If the preamble wasn't just 25 numbers, but it was like 1,000 numbers, then you would need some optimization like that, because otherwise this is like an n cubed loop, right? This is 1 4, 2 4s, 3 4s. So that might work for 25, but it definitely won't work for like 1,000 or 1,000,000. But the problem was small enough that it did work, and so you could just brute force it. Yeah, I'm happy with that. That's actually one of the lessons for programming, right? Like, obviously you should always optimize whatever you write, especially if you're going to push it into production. But sometimes, either when you're prototyping or when it's a small enough case that it's okay, especially as an engineer, right? You need to balance your time with what you produce. And sometimes, depending on the situation, right? If it's not like business critical code, but it's something that is reasonably brute forceable, and most use cases are small enough, and you don't foresee it being bigger until ages down the line, it's okay to push some code that isn't fully like the most optimized it can be, as long as you either put together a ticket and say, hey, this needs to be looked at some point when we get more customers, or whatever. As long as you have a to-do or a ticket or some way to know that this is a bit of code that needs optimizing at some point, maybe if you can put in some monitoring to check and say like, hey, if this bit of code ever takes more than a minute to run or whatever, then we probably need to look at some ticket that you've referenced. Like that's the point of engineering, right? Engineering is about balancing time and the quality of what you produce. So yeah, so that's just something to keep in mind. And then the second half of this question, I feel like what I wrote could miss the result if you had some specially crafted input, because I kind of assume that, actually, is that even true? That's probably not true, right? No, forget what I said about that. This bit of code should always work for any kind of input. So all I'm doing is I'm starting from the first number. I is the beginning of my range, and I'm just keeping on adding numbers, because if you add a positive integer, it's always going to keep going up, right? So once you get past whatever your target is, you know that you're never going to be able to get that number. So yeah, so it's fine. So I'm just starting from the first number, adding it, or keeping on adding numbers until I either reach the target number that I want to hit, and then in which case I've solved the problem, or I go past larger than that number, in which case I know that this isn't possible if I'm starting from this number, so I start from the next number, I go again. So this time this is a n squared loop, right? There are 2 for loops. This is big O of n squared, is the way we say it in computer science. But yeah, again, this input was small enough that it was fine. And my mistake was just not reading the question properly, which I do a lot of when it comes to these challenges. I skim it and try to get it done as quick as possible, and I end up losing myself time. Because you can only submit one answer every minute. So if you mess up, you have a 1-minute penalty, basically. Yeah, so I thought it was add the first and the last numbers, but no, it's add the smallest and the largest numbers. And so that's what this little bit of extra code does. I just set the smallest and largest to the first number, and if I ever find a number smaller than it, update the smallest. So if I ever find a number larger than it, I update the largest number, add them together, and that's the result. So thanks for joining me today. It was quite a straightforward problem today, nothing too special to talk about. Yeah, cool. So yeah, I'll see you tomorrow.